Good afternoon, dear learners. This is your chemistry tutor, Charles Kwame Bando, handling the general chemistry course. The code is EBS132, and as I have been telling you, this course is being handled with myself and then Mr. Amako, Stephen Kwame Amako, and this is the unit 4. And in unit 4 we are definitely looking at chemical formula and then equations. But before we start whatever we are supposed to do, I will urge you to make sure that you obey all the protocols that our dear president has put forward that we should follow, so that at least you save yourself and save others as well. And so you know that the COVID-19 is very real, and as you move about, if you don't have anything so urgent and so important to do, I wish that you stay home. And then whenever there's the need to go out, you go with your face mask and then sanitizers as well. Please, your life is very much important and dear to us. So try as much as possible to obey these protocols. The washing of hands, wearing of face masks, and then social distancing and the rest. So that when all is set and when everything calms down, then we'll meet together and then go on with life as it's supposed to be. Thank you very much for your attention as far as this is concerned. Alright, so let's look at what we have for the day. And before we continue, we want to look at our performance indicators. In those days we call it specific objectives or objectives, but now we are only calling it performance indicators. And so by the end of this lesson, you, the learner, should be able to use the periodic table to illustrate symbols representing their respective elements. For instance, magnesium, if you see Mg, you should know that it represents magnesium. If you see Al, you should know that it represents aluminum. If you see sodium, Na. If you see H, you should know that the H represents hydrogen. There are a lot of them. Like if you see K, you must know that it represents potassium and all of that. Alright. Now you should also be able to indicate the symbols indicates that the symbols represent the atoms of an element, and write the formula of 4 common compounds, and then outline the steps involved in writing a chemical equation, and then also write a balanced chemical equation for a simple reaction. Right? And then also to indicate symbols like G for gas, L for liquid, S for solid, AQ for that is a solution or any compound that is being dissolved in water, that to denote the states of a substance in an equation. So mostly in any chemical equation there is the need to show the various states of the compounds that are forming the equation. So if you see S attached to any compound, that means that compound in the equation is in its solid form and all of that. So at the end of this lesson, if we're able to come out with these steps, then we will say to ourselves, learning has really occurred. And if not, then of course we have to revisit the lesson again. Right. Now we are going to briefly look at the periodic table. We are not going detailed, but just a brief introduction to the periodic table. If you need a detailed work, then you have to read wide. Right. Good. Now we are saying that the periodic table is nothing but it's a table that shows the arrangement of elements. We have this arrangement in a horizontal manner and then also in a vertical manner. Now the horizontal row, we call them periods, and the vertical ones are called the groups. Now this is being done according to the number of protons in the nucleus, or possibly atomic number. Don't forget that in our lesson 1 we told you, or we said, that the number of protons in an atom is the same as its atomic number. So this periodic table of elements, the elements have been arranged in the order of their increasing atomic number. Right. So this is just a simplified version. Please, this is not the entire element in the periodic table, but for the sake of what we are supposed to do, we're only using this, just a section of it, to show you how the arrangement is done. So you see that in the table, you see we have what we call the S block, we have D block, we have P block, we have others. They are quite S, P, D, F, and the rest. But because of the type of chemistry we are, or the level of our chemistry, I don't want to bother you with these blocks. When you go do a little further of chemistry, you talk about orbitals in any shell. We describe the shells of atoms like the K shell, the L shell, the M shell, the L shell. Each of these shells, there are sub shells or subdivision that we call them the orbitals. So for instance, if you take the shell number 1, which is the K shell, it has only the S block, and so it takes a maximum of 2 electrons. If you go to the next shell, which is the L shell, it will have the S and also the P, and so on and on and on. I wouldn't want to bother you with that. Right. Now you see the periodic table. You see G1, G2, G3, G4, 5, 6, 8, 7, and all of that. Now we also have the period as well. So the G1, what it means is that all elements in the G1, we call them group 1 elements, and they all have 1 electron in their outermost shell. They have 1 electron in the outermost shell. So if you see lithium, sodium, potassium, they all have 1 electron in their outermost shell. Now the group 2, whereby we have the barium, the magnesium, and the calcium, they also have 2 electrons in their outermost shell. Now down to group 8, the group 8 element, they have their outermost shell fully filled with 8 electrons, and they are noble gases. They are unreactive. Now the reaction of atoms as a result of unfilled electron, that is the valence shell, the outermost shell. It's just like as Bible says, no good for a man to live alone. So in as much as you want to fulfill a vacuum in your life, you go and then you marry so that that vacuum is fulfilled. Some men marry because they feel lazy when it comes to washing. Some of them cooking. A whole lot of reasons why men marry. Now in the case of the atoms, they also react because the outermost shells are not fully filled. Those ones with fully filled outermost shell, they feel they don't need anybody and they don't react. So helium, neon, argon, krypton, and the rest, they are all noble gases. Okay, so let's continue. Now we are also adding up that a chemical symbol is nothing but that which represents 1 atom of an element. So for example, as I indicated earlier on, if you see H, it means 1 atom of hydrogen. If you see Li, it means 1 atom of lithium. If you see Ne, it means an atom of neon. If you see Cl, it means an atom of chlorine. If you see Mn, an atom of manganese, and on and on and on. So we are only saying that when you say chemical symbol, it represents an atom of, so 1 atom of an element. Okay. So with the periodic table, so as a deeper thought, we are saying that the periods or the period is a set of elements which have the same number of shells. The same number of shells. and whose atomic numbers increase by 1 unit from one atom to the next. Good. So we are saying that the periods, they are atoms having the same number of shells, and their atoms, so their electron number increase by 1, or possibly atomic number. Don't forget that the electron number in a neutral atom is the same as the atomic number. So we are saying that the atomic number increased by 1. So let me send you back to the periodic table and you watch something. Good. So you see that K and Ca, they are in the same horizontal row. So what it means is that they have the same number of shells. When you look at Al, Si, Ps, Cl, and Al, so Ar, that is argon, they are also in the same horizontal row, and so they will be in the same period and they have the same number of shells. Alright, thank you. Let's go back. Good. So we are also saying that the group is also a set of elements with the same number of valence electrons whose atomic number also increase. Don't forget that I have said already that if I say group 1, then all elements with 1 electron in the outermost shell form that group. If I say group 2 element, I am referring to elements with just 2 electrons in their outermost shell. Good. Now, as we move on, we are also adding that the periodic table is blocked according to the electronic configuration of elements, and then increasing atomic number, right? So the periodic table is nothing but just the arrangement of electrons, as we have said, so arrangement of atoms, as we have said already, and this is done in accordance with their electron configuration, and then the increasing atomic number. That is why you see hydrogen number 1 on top there, because it has the least atomic number. Okay. Now, elements in the s block have their valence electrons in the s orbital. I told you I don't want to bother you with orbitals, but we have to just mention it. So if you see element in the s block, what it means that they have their outermost electrons or the valence electrons in the s orbital. Those that will be in the p block will also have their valence electrons in the p orbital, and then on and on. Good. Alright, so elements with their valence electrons, as I said, in the d orbital will also occupy the d block and are called transition elements. So when you see any periodic table, the elements we call them transition elements, and they are the one that occupies the d orbital. The valence electrons are in the d orbital, right, and they are called transition elements. Good. So these are some few information that I want you to know about the periodic table. So there are a lot of blocks. We have the F, but we are not going to. I don't want to bother you that much with that one. Good. So let's look at what a compound is briefly. We have done this already, so nothing. We are just a recap, because we are going to look at how we will write chemical formula for compound. That is why we want to mention what a compound is. Good. So we are saying that a compound is a substance formed by a chemical combination of 2 or more different elements. Here the word chemical combination is very important, because mixtures are also as a result of 2 or more substances, but then it is by physical combination. So as soon as it's a chemical combination of 2 or more substances, then we are talking about a compound. Now in compounds, we also add that new substances are formed. Don't forget that we will do mixtures right after this, and you realize that in mixtures, no new substances are formed. In mixtures, no new substances are formed, but in compounds, new substances are formed. Alright. Now, we as ADAP, we also say that the new substance that is being formed will have an entirely different properties from the original element or from the constituent element. But in mixtures, we will also see that the mixture, individual elements in the mixture retain their original properties, right? But with this one, the individual cannot, but it's the new substance form have a different properties. For instance, if I should mix hydrogen and oxygen and they react chemically to form a compound we call water, you realize that this compound called water has different properties altogether, because of course water, hydrogen H2, which is a gas, exists as a gas, and oxygen, which is also O2, that also exists as a gas. But water can exist as gas. It can also be as a liquid and even go to the solid state depending on the temperature changes. Alright, so the properties of water is entirely different from that of hydrogen and then oxygen. Now we are also saying that compound may exist as a solid, it can also exist as a liquid, it can also exist as a gas. So compound can be found in the various states of matter. There's three main states of matter. Matter has more than 3 states, but we are only looking at the solid state, the gaseous state, and then the liquid state. So if I pick chalk, which contains calcium carbonate, it's a solid form of a compound. If I pick sodium chloride, if also pick water, petrol, it's also a liquid and it's a compound. Again, carbon dioxide, ammonia, sulfur, they are all compounds but in different states. That is the gaseous state. Good. So this table is showing us various compounds with the elements present and then their chemical formula. So I have with me water, which contains hydrogen and oxygen, and then the formula is H2O. You can also see sugar. I wouldn't mention almost everything. This is just a reading material. So in order not to waste your time, I'll just leave it, then you now read it for yourself. We have sugar or glucose, which contains the elements carbon, hydrogen, and oxygen, and the formula C6H12O6. Then we have also a compound we call chalk, which contains calcium, carbon, and oxygen. So it's CaCO3. Good. So read the remaining ones for yourself. Right. Good. Now, please, as we move on, I will urge you to, tighten your seat belt a bit. We are moving into how we can write a chemical formula for any compound that may be given unto us. And please, I want to urge you that this is very simple. If you pay attention, you realize that it is very simple. I know some of you are afraid of some of these things based on some reasons that are best known to you. Some of you don't want to see this type of chemistry at all, but you cannot also do away with them. They are part of us and it's very simple. So just pay attention and it will be simplified for you. Good. Now we are saying the chemical formula is expression of symbols, the names and number of different elements forming one molecule of a compound. Right. Now we are saying that if you see a chemical formula, it is just an expression in symbol form or expression of symbols that represent a name of a particular compound or one mole of a particular compound or one molecule of a particular compound. For instance, if I write H2O. If I write H2O, that H2O represent one molecule of water. So the name of the compound is water, but H2O is the symbol, or sorry, is the chemical formula, which is the expression of symbols, right? Now, for example, as I have said with water, if you see NH3, it represents one molecule of ammonia. One molecule of ammonia. And it means that it contains nitrogen and then 3 atoms of hydrogen. Good. Also, if you see potassium chloride, KCl, it represents a molecule of the compound. So it has just 1 atom of potassium and then 1 atom of chlorine. So the chemical form, we said that it is the expression of symbol, the names and number of different elements. So once you see the formula, you should know the number of elements present in there. Right, you should know the number of elements present. Good. Because if I just mention ammonia, the name will not give you the various elements, but if you see the formula, you will know the various elements present. Good, so we are going to look at the various steps that will help us to write a chemical formula. The various steps. These are just simplified, so just watch it. Now the very first step is to write the symbol of the element involved. So as an example, we looked at magnesium and oxygen. If I want to form or write a chemical formula for magnesium and oxygen, a compound formed by magnesium and oxygen, the very first step is to write the symbols of the elements. So as we have dealt with already, the symbol for magnesium is Mg and the symbol for oxygen is O. So that is the first step. The second step is to indicate their valences below them. Someone will say, what then is a valence? We have dealt with valences already. So if you have forgotten, you have to go to Unit 1 and revise it. But here I will only tell you that for valences, if it is a metallic element that is then equal to the number of electrons it will donate. For instance, sodium will donate 1 electron, and so its valency will be 1. Now if it is an ion, it is the number of electrons that it will need to form a complete outermost shell. Right, if it is anion, for instance, chlorine has 7 electrons in its outermost shell and will need just 1 electron, and so the valency of chlorine is 1. Right, so possibly this is what I'll tell you for now. So if you want more information on valency, go back and revise Unit 1. Good. So the valency of magnesium is 2, and then that of oxygen is also 2. Right, now for magnesium, it has 12 electrons in the whole atom, and so first shell takes 2, second shell 8, the next shell takes, so the 2 electrons are in the outer shell. So magnesium always donates that 2 electrons to form a positive ion that we call cation, and it is always Mg2+. Now for oxygen, the 2 is not the number of electrons in its outermost shell, but it is the number of electrons oxygen needs to form a complete or a fully filled shell. And that is why we have the 2. So I have indicated the valencies below them. Please follow the steps, very simple. Now the next step is to interchange their valencies and write them as subscripts. Interchange their valencies and write them as subscripts. So look at this. I do that. So I give 2 of magnesium to oxygen and 2 of oxygen to magnesium, and I write Mg2O2. Mg2O2. So that is the third step. The last step is saying that reduce the numbers to their simplest ratio. So the ratio 2:2 is the same as 1:1. So I now reduce this Mg2O2 to MgO. MgO. So that is the chemical formula for magnesium oxide. Magnesium oxide. I hope I told you that the steps are very simple. Please, this is for the sake of teaching. If you are writing it anywhere, still you can still go through this process. But if you know what you are doing, you can also just write it straightforward MGO and then you go. No examiner will ask you to show all these steps for anything, but because we are learning, we want to let you know what goes into it so that step by step you will be able to know what you are supposed to do. Good. Now let's look at another example. We are looking at aluminium and then oxygen. Aluminium and then oxygen. Good. Having the steps, we have done the first step by just writing the symbols of the element. Now the next step is to write their valencies. So I want to know from you, for the valency of oxygen, it has been stated already, so we know. But I want to know the valency of aluminum from you. I want to know it from you, because you should know the number of electrons in the outermost shell of aluminum, and you should know that aluminum will give out that particular those electrons to form a cation. And I know if you said 3, then you are right. If not, if your answer is not 3, then please go back to the first unit and learn about electron configuration. Okay, so here we have 3 against 2 for oxygen. So what do we do then? The next step is then let's interchange their valencies. So we have done that. So 2 for aluminum, 3 for oxygen, and then we write them as subscript. So we are going to have Al2O3. Now the last step is saying that we should reduce the ratio to the simplest form. And of course 2:3, we cannot reduce it further. So the chemical formula for aluminum oxide is Al2O3. So what it means is that 1 molecule of aluminum oxide contains 2 atoms of aluminum plus, also against 3 atoms of oxygen. Now somebody will ask why? Why not 1 against 1, just like magnesium and oxygen? Now it is not possible, because when you look at an atom of oxygen is looking for 2 electrons to form a complete outer shell. Now if aluminum is also ready to give out 3 electrons. So if aluminum should bond with just 1 atom of oxygen, then of course that particular bond will not be possible, because when aluminum gives 2 electrons to oxygen, where will the last electron go? And that is not possible. So let's see if we should bring another oxygen to have 2 atoms of oxygen against 1 atom of aluminum. Let's see if that will also be possible. That is also not going to be possible, because the 2 atoms of oxygen will now require that they are given 4 electrons to share 2. But then 1 aluminum is giving out 3. So they will still need additional electron. And so that will not be possible. Then when 3 atoms of oxygen come together, they will require 6 electrons. But an atom of aluminum can never provide 6 electrons. 1 will provide 3. So there's a need for aluminum to go for a brother aluminum, and then the 2 will give 6 electrons, which will be shared by the 3 oxygen atoms, so that will form a complete bond. So that is why we have Al2O3. Okay, so I believe now the steps is very simple to you, and so whatever compound given to you, you can now write the chemical formula going through this step. If not, you have to revisit it all over. Good. Now, so we are going to look at what we mean by binary word compound. The word bi means two, so all compounds that contain two atoms only are called binary compound. Example like the sodium chloride, sodium and chlorine, they are just two, right? Good. So we have sodium chloride, NaCl. We went through the steps, we have done that already, so this is just showing you what the application of the steps that we have done. Good. So I have given this trial questions for you to try your hands on. This is a trial, but unfortunately the aluminum and oxygen we have done already. So try to do calcium and oxygen, carbon and oxygen, nitrogen and hydrogen. These are trial questions for you, so try as much as possible to write it. If you are not able to do, then I'll urge you to go back to the previous slide to learn how the thing came about, how we write it. And if you're able to do this, then you have to go. If not, don't continue, but go back and revisit it. All right.